What is friction? I will start from the basis. Friction. What is friction? Friction can be defined as the force that exists between two surfaces. Oh, the surfaces better. Two bodies in contact. What's the meaning of this? It means that if two bodies are in contact, there's bound to be friction. For instance, for example, a box placed on a flat surface. Let me just draw that so that I can be happy. Let's say this surface here, this one here, this one here. We have this box here. Someone is disturbing with a call here. I'm very sorry. Sorry, sir. I'm in a class now. Sorry, sir. I'm in a class now. So I'm very sorry for that break. Let me just put the phone in vibration so that it won't be disturbing us again. Now, just like I said, this box here has a mass of its own, has mass M, but the weight will be acting downward. Let's say this is the mass, the weight is acting downward, that's W. Why? There will be reaction up like this. There will be a reaction up like that. So without friction, there must be a force pulling it this way. Let me say FPA, pulling force. Yeah, if the force is going one direction, the friction will opposite in the other direction. The friction will opposite for sure. I will always use FR for it as what? As friction. Now, up here is called reaction. I will tell you the purpose of everything here later. Here is weight. Weight. Now, what do we have here now? We now want to look at the types of friction that we have. Or before that, we need to discuss the properties of friction. Some will say characteristics of friction. What are the properties of friction? Those are the things we need to know. So, properties of friction or characteristics of friction. Properties of friction. It has four properties. Number one, it is directly proportional to the normal reaction. R. At times they might say that, or we just say that it depends. Someone is making a noise there. Please mute yourself. It depends on the normal reaction. Number two, that we have in friction is that it always depends on one thing. It depends on the nature of surface. Nature of surface in contact. Then the third one, let me see whether I can erase this. I don't like the way it is written. In contact. Let me put it there. Okay. The third one, it is independent of the velocity of one body over the other. The fourth one, it is independent of what? Independent oh, I moved off here. Of surface area of contact. So those are the properties of what? Of the friction. The next thing we want to write here is the types of friction. Types of friction. We have two types of friction. There are two types of friction. Namely, one, static, or stationary, or limiting frictional force. Number two is kinetic, sliding, dynamic, frictional force. We have these two types of frictional force. There are reasons for those names, and they mean the same thing. It depends on the context of the definition. I want to go to the definition of both frictional force now. The first one is the static friction. Static friction. First one is static friction. That static friction can be defined as, this can be defined as the force that prevents a body from moving. Or we say that it is the frictional force between sorry, someone is trying to call, okay, he's in already. There's a message here. Sorry, sir, my battery is about to die. Oh, sorry about that. I too am running on jet. Force between, it is frictional force between two surfaces when a body is stationary, not moving, or static. That's why they call it stationary or static frictional force. Why is it limiting? You will get it limiting when we get to the point when I need to explain this. Now, let's take that example again of a box. Of mass M on this place. Someone is making a noise. Please, Adebayo, move, please. Move, Adebayo, please. Yes, now, when the force is applied here, the pulling force is applied here. Mr. Adebayo, please mute. I'm trying to mute you. I don't know what is happening. It's not muting. Thank God. Now, it's applied there. At the left side, since the force is acting at the right side, So the frictional force will act at the left side. The reaction will be up, but reacting to the weight down there, E is equal to mg. Why the reaction is up like this? Now, what do you think will happen as the force here, Fp, is being increased? When the force at the right side is increased, then the frictional force will increase. The rule here is like, we're talking about tug of war. If you have ever participated in tug of war before, when the side pull the other, try to pull. As you are increasing your own force, that will also increase force. Increase force, so it's like there's a pulling force and reaction, and a friction at the other side. As you increase your own, you just that naturally the other one will also increase, that we can't move. We won't move. So at that point, it means that both of you, as the one side is increasing, the other one is increasing. Until it gets to the limits level, that you get to the maximum level. That is the limit you can go. And that is why it is called limiting frictional force. Once you don't get to that level, this pulling force Fp cannot move this body. So why they call it limiting frictional force is because you must get to the maximum level, the limit of the force you can go to. And that is why it's called limiting frictional force. But what we want to get from here is that if man decides to increase this mass, let's say we increase this mass, we increase it with another mass, m prime. Then this one will increase immediately. It means what we are getting here now is what? We are having this and small one up there, m prime, n. So here our weight has increased to what? To m plus m prime times g. While the reaction will definitely increase based on the weight. So the force, pulling force here is the Fp, while this place is Fr. Now, the rule here is that as the mass increases, reaction increases. So when the mass increases, frictional force will naturally increase. So when this happens, it means that the frictional force increases as R increases. That is where we got the rule that as reaction increases, frictional force does what? Frictional force increases. And there's a law there, that law, the formula I said, that this means that is the frictional force is directly proportional to reaction, normal reaction. That is, what we are saying here is that Fr is proportional to R, and Fr is equal to mu R. Where that mu, they call it mu, that constant, is the proportional constant called coefficient. coefficient of limiting or static friction. Static friction. And that mu is found with what? Mu equals FR over R. This is the case here. Now, usually, we now have equation now. This is the first equation we are having here. Now, if the body is not moving, pulling force, you must get this through. Pulling force equals frictional force. That is, the pulling force at that time will resonate, the frictional force will resonate with what? With the power of the pulling force. I believe you get that right. We have the first thing you must note here. When the body is not moving, it means the body is FP, the pulling force equals frictional force. This one, the way they say it, they will say that the body is at the verge, of sliding. Or they will say that the body is just about to move or slide. If I ask you what is the force needed to just move the body, we are talking about FP equals FR. That's the first equation you must note today. When that one is noted, we now go to what is the kinetic friction. Second part of the discussion is what is kinetic friction. What we are still discussing here is what when the body is just on horizontal level. Kinetic friction. This one is defined as, this can be defined as the friction of a body when it is in motion. Now, I don't need to talk too much here. This kinetic frictional force is always less than, it is less than limiting frictional force. Why is that so? The reason is that as you increase the pulling force, frictional force increases. You increase it, frictional force will increase. It will get to the highest limits. Highest limits. That's what they call limiting frictional force. Once you get to the limit, that force will break the frictional force and it will be moving. When the frictional force is broken, the frictional force cannot maintain the highest level again. It will go down. The example I gave you the other side, like tug of war, if you have experienced before, if you are on the side that they are pulling, you have the power, or the side that the power is not there. If your power is overcome, you will see that you find it difficult to resist, you just be moving, they don't be pulling you like that. Once they start pulling you, because the frictional force has reduced, by that time you can't exert any force again because you're already moving. So that is why the kinetic frictional force is always less than the limiting frictional force. And that one is normal. The formula I gave you the other time is what we are going to get here. But how do we calculate? What do we calculate here? Let's see the equation that is attached to this frictional force. When the body is like this, there is weight downward, and there is force here, pulling force. Reaction will always be here. Here is the frictional force. Now, the pulling force, in this case, the pulling force will make the body of mass m accelerate with an acceleration of acceleration A so that means that the pulling force has increased. The pulling force has increased by a moving force V, moving force F. So as a result, this means that is the pulling force is now equal to the moving force plus frictional force. Don't forget that the moving force is always mass times acceleration, while the frictional force is what? Mu R. From this, we can now say that this moving force or the pulling force has increased. So the meaning is that the pulling force cannot pull it unless it adds the moving force to it. That is why it is now moving. But don't forget, LP will now give you MA plus mu mg. And that is the equation you must note at this point when it is moving. Then, with that, how do we find the coefficient of kinetic friction? It is still mu, where mu is taken to be F over R, and that will give you MA over what? Over mg, because R equals W in this case. They are horizontal level. So with this cancel this. Our coefficient of kinetic friction of the kinetic friction can be defined as acceleration over g. So this is where we're going to stop for now, and maybe tomorrow or Sunday we shall be having the conclusion part of this friction. And the next thing we are discussing, by God's grace, is going to be what? So next will be what? Is friction on an inclined plane. So that will be the next class. To see me or call me or get information on what to do, you can contact me on what we have down here. And that is what? The phone number on what? 080-2270-6148. And with this, you will see me there always. Then down there, you see the description. In the description, you will see the WhatsApp group where you'll be getting information from time to time. I remain your one and only coach in mathematics and physics, Tajuddin Ugono. See you when I see you, and bye for now.